Gadget UK here again, a super short video. I covered this particular fix and there's more about this in part 2, there'll be a link up there, part 2 of the AJ multi-fix video. I also briefly touched upon the issue on Tom Meads' scan doubler repair there. So when using an official Amiga 2000 power supply, it provides a tick signal. What is that? 50 or 60 Hz reference signal. Comes from the power supply. And that goes via J300 back here, you know, from the power supply into the CIA. When it's wired that way, you don't get problems with scan doublers and stuff, and other graphics cards and stuff that use the C-Sync, actually, not the V-Sync. If you've not got an official power supply, and I haven't, I've got an ATX adapter here, you have to switch this jumper over to the right here to pull the tick signal from Agnes. It uses the VSYNC signal. And this is where problems start. Graphics cards like that, the scan doubler, won't work. And there's more about this in the video I mentioned earlier. But essentially, I think in layman's terms, what's happening is the long trace from VSYNC here through the jumper to the CIA, some noise is picked up or reflection. The VSYNC coming out of Agnes I don't think is buffered, which means any reflection can interfere when it's merged with the H-Sync, and this produces C-Sync, and a lot of these graphics cards do use the C-Sync. So I think that that is the issue. So obviously there's multiple ways you can fix that. You can get an official power supply that provides the tick signal, so you don't need to use the VSYNC. You can also get a 555 timer or something similar to produce a 50 or 60 Hz tick signal there to feed into the centre of J300. Or you can do what I'm going to do in this video, which is I've got a chopped off Molex connector here with the 5 volts and grounds connections, a short wire to solder up there. I'll get some heat shrink to join that up. I've got a little SOT23 adapter here, so it adapts from SOT23 to DIP. And it just means that it's easy to, well, once you've soldered the little SMD component in the middle there, it's easy to solder wires to the pads that branch out on the edges here. And I've got 2 of these here, a male to female DuPonts. All you need is a wire with a female DuPont there, so you could get the connector separately and assemble it on your own wire, but I've already got these pre-assembled ones, so I'll literally chop the ends off here. And this is the chip here, a Schmitt. It's thanks to Stephen Leary that's had this idea. Yeah, it's a Schmitt buffer. I'll stick the part number up there. If you don't feel comfortable soldering little SMD parts like this, what you could do is just get a DIP chip. I'll stick an equivalent part number up there, you know, like a 7.4 series, something like that sort of size, or a bit smaller probably. And trim the unused legs off and just bend out the legs you need. And you just need the ground, the 5 volts, an input and an output. So it's like 4 wires effectively, and that's why we've got 4 wires. I will also stick a 100 nanofarad capacitor. I'm going to use an SMD one out of my SMD capacitors there, and I'll just solder it onto either the 5 volts to the ground and use a little wire to join across to the other connection, you know, because the capacitor wants to go between 5 volts and ground. So I'm going to start by getting the Schmitt buffer on here. So if I just peel this back and lob it onto the table, you can see how small that is. I mean, look at the size of my thumb, it's tiny. So yeah, it's just a case of putting it onto the PCB without dropping it here. Obviously the right way up, I think I've just inverted it. Yeah, but you want to, you know, move it around until those pins are all on the traces that go like that. You know, you've got 2 halves, one for each half of the chip here. So it has to be bang in the middle. And as I say, each one of these 3 connections on this side here want to be aligned with the pads. And then it's a case of just holding it down with something, I don't know, like this maybe. Use magnification and solder a point, and then just inspect to make sure it's still straight. You've got 3 pins on one side here and 2 on the other, so it's just 5 points to solder, but it is very, very, very small. This might be why it's easier to use a DIP chip like that. This is a different type of chip, and it would be a bit shorter than this, a Schmitt buffer. But you could, let's say, just trim off any of the legs that are not used. You just want the input and the output for 1 gate on there, and the ground and the 5 volts, 4 pins you would need to leave on. So on Super Macro there, you can see that's pretty well aligned. I just now need to hold it in place and very carefully solder 1 pin. It will probably move when I do that. I'm not going to be able to film this, I just don't have a microscope or anything to you know, be able to assist with that. Yeah, I'm just putting the solder nearby here so that I can, well, use magnification, hold the component into position, and get some solder. Yeah, hold it down and then just solder 1 pin, a bit more soldering. Yeah, so you can see it is slightly crooked now, but we've got that little bit of solder on the right hand side there just holding it. So what I would do now is just get a little bit of flux around this, add some solder to the points on the other side, that'll secure it, and then drag solder across here with a bit of flux. I can show you that bit, I think. Yeah, so the point I soldered is on this side now. I did just straighten the chip ever so slightly by using magnification, heating that one pin and using my little tool there to move it around. But now it's secured on one side, we'll just add a wee bit of solder on that pin there and on that one. Yeah, you do need to use magnification when you're dealing with something this small. And we'll get a wee bit of flux on there in a minute. Yeah, I've got some solder on the other pad there. So let's now add some flux. And if you go with the SMD chip like this here with the adapter, you do need a dedicated flux. My solder contains flux, but if I was using a little dip chip that's bigger, you wouldn't need any dedicated flux. And you can see what I'm using here. I'm using the SMD 291 NL from Chip Quick. So this is the side where we had one big blob of solder there, and I'm just going to heat it and then push that way over the other two pins, and then drag forwards and backwards a little bit, remove the solder from the tip, and just bob in and out, and then I'll inspect with some magnification. I'll refloat that side as well too, on that side, and I'll give you a close-up. I'm just going to clean that with the cotton bud and some IPA. And there we go on macro, so you can see that's the side with the 3 solder points. I did touch the pads to the side, doesn't matter, and then the 2 solder points on the other side as well. And using these breakout connections, you know, each one of these pads here goes to one of the pins. Yeah, work out which ones go to which pins and just solder. Right, ground and 5 volts, the in and the out. And obviously it's going to be red for 5 volts VCC, black for ground, and then I've gone with colour designations that kind of make sense. I, indigo, in, I for in, indigo, in, orange, O, out. Yeah, so it'll be easy to not mistake those. And because I've got these male to female ones, I'm just going to trim them off here. I could, take the housing off there and, save a little bit of length of the wire, just a tiny little bit, but there's no point. I'm not going to reuse those connectors. And obviously this is reclaimed, it's yellow there. Yellow is never a good colour to use for 5 volts, but that's how this was wired. And that is 5 volts and ground according to, an ATX power supply pin out here. But I'm just going to reuse this, and I'm going to just do this by carefully snipping around the edge of the wire here. Just a little bit, snip a couple of different orientations to the very edge, just nick it. Don't cut the wire. And then just carefully pull like that. Yeah, that's not the best way of doing it because you could pull it out of the crimp connection inside, but that is going to be fine. So you could just get, a male to female splitter. It could be a 2-way one or something, and then you can just chop one of the connections off and solder straight to the PCB. But what I'm going to do, obviously, here is extend this, put some heat shrink, and then solder that onto the PCB. I'm just making use of odds and ends. It's often what I will do on my channel. Connectors like this that I've salvaged in the past, they get a chance at a second lease of life. They get used somewhere else. I don't even know where this came from. I think this came from a fan at some point, maybe like a 5 volt fan. Yeah, so we'll just twist the strands together there. So solder containing flux, just heat the wire and the solder at the same time. There we go, that's one. Let's do the yellow, which is going to be red. Right, those are tinned up. I've just split the red and the black there because it's one of these cables where they're kind of joined together. And we'll do exactly the same thing here. Solder on those, tin them up. And then a small section of heat shrink tubing. You can get this in different diameters and different colours. I'm just going with what I've got again. So yeah, blue, it's not ideal. You want black or something. You could even go with a red piece and a black piece, one for each side here. So what I'm going to do here is just make sure this is going to be long enough, and it's not. It's going to block the end. So we'll just strip this back a little bit more like that, so they can slide all the way right down. This is an unnecessary step. If you've bought a male to female, you know, Molex cable or a splitter or something, you'll just be chopping the end off, turning it up. You won't need to solder on like I'm doing here to this. If you get these just right, you'll find it's almost impossible to break the connection generally when they're side on with each other. I just want them to be as in line with each other as possible. There we go. Leave it for a sec. So those connections there are going to be robust enough. Slide the tubing right up into the thing there like that. Hot air 150 degrees here. Just shrink the heat shrink. And that'll just hold in place and keep those isolated from each other and from anything else in the system. So as I say, if you went for a splitter, you know, because you can get one of these that goes to two of the male ones, and if you got one of those, you'd just be chopping one of the ends off, and you'd be in this same situation now where you've got your female part and you've got your, you know, your two wires that you're going to solder. Bear in mind, if you get a splitter, it's going to have two extra connections there. You have two grounds in the middle, and you have plus 12 on this side, and plus 5 on the other. I'll show you the colour designation on the ATX one when we test it in a minute. It's like yellow for plus 12, so again we'll just split those apart a little bit. We don't need them separate too much, and I just need to just look at the pin out of this again and solder the black to the ground wherever that is, and the red to the 5 volts. So I'll report back when I've done that. If you use thick gauge wire like I have, and most Molex adapters will have thick wire, you're going to probably have to do the same thing where you just, you know, tin them up. You won't be able to feed them through the holes in that little adapter board. The holes are too small. And depending on the thickness of this stuff, generally you can cut it with scissors to get a reasonably straight line. And then what we'll do is slide this over these wires here. The idea being that this is going to be in the centre of this, yeah, secured inside. And on the other end here, we're going to have the two wires coming out. Should make it nice and tidy. So I'll stick the smaller piece on and put the big piece back on again. The idea being that what we might be able to do is shrink this right down and then slide this up over the edge of it and then shrink that, and it's just going to hold the whole thing in place. But we can just slide those right down for the moment because we don't need them just now. Right, we're all done. So we've got our two pieces of heat shrink here ready, and then here you can see I've soldered the ground on. So as the 3 pins are on the bottom here, it's the right hand one that the ground goes to. And when I soldered this, I'm being very careful it doesn't short to the centre pin. Now the centre pin, I can solder the other wire, you know, the input and output. I think one of them goes to that centre pin. I can solder on this side here, and I'll do the same with the other. You know, the input and the output can be soldered on this side. That's the nice thing with these adapters. But you can also see where the 5 volts is. So you've got 2 pins on the top side of this chip. The left hand one is 5 volts. And what I did is just cut this one down a little bit and then cut it back, soldered so that it's almost straight here. And then when it goes into the tubing, it's it's not going to get stressed and stuff. You could also put a cable tie around that before you slide this over, and the cable tie will stick out in here and sort of wedge itself in. That's something you could do. I'm not going to do that though, because it's not going to be subject to pulls and tugs and things. And you know what? It's going to be pretty resilient with the heat shrink tubing over there. So the final step now is the purple and the orange, you know, in and out. As I say, I'm going to solder those on the connections on this side here, and I'll show you that in a minute. But before I do that, I'm going to do the same thing I did here. Slide a small piece of heat shrink up there, like that one. Yeah, just tinning those up. The gauge of that wire is really thin, actually. So back to our pin out. Y is the output. So that's the side where you've got 2. It's the other one. One opposite 5 volts. That's the output. And the input's the middle of the side with the 3. And that's it. We just need to just slide the heat shrink down. I'll show you the solder points on there first, and then we can test it. So you've seen the other side already, so you can see there where I soldered those. I'll just flip that over so you can see the orientation. Yeah, we've got 2 pins on the side with this red wire here, and 3 pins on the top side there, so the focus went out a little bit there. So we just need to simply slide this over the PCB like that. Being careful not to damage our wires. Right, so I'll show you this as is. The jumper J300 is set to the right there, which means take the tick from Agnes, take the VSYNC into the CAA here. And if I switch this on, the scan doubler is connected up as well. So I've got the RGB output there as normal. And as I say, the scan doubler is connected and the VGA is going to the LCD screen here. Periodically just watch, do you see that flicker? So this is the VGA. Yeah, it can't lock on. There's something not quite right with the frequency there. So this is where this mod, there you go, saw that then, out of range I think it said. Yeah, so this is what this mod does. So if we switch this off, and if we connect up to, and this is where this mod comes into play. So here's one of the Molex connectors. I was going to show you that before, wasn't I? So yeah, red 5 volts, yellow 12, 2 grounds in the middle. So yeah, do make sure if you've used a connector like this, like I've got, that it is going to the red, the +5. The part we're using here is a 5 volts part. It'll work between 3.3, I think, up to 5.5 volts. Yeah, anyway, that's that. And then we've got the 2 wires here. And with our 2 wires here, we can simply pull off J300, yeah. And I, indigo, is input. That wants to go to the right hand point. That's where VSYNC comes out of Agnes, yeah, into the jumper. And O for orange, the output, goes into the centre pin. And then all being well, provided we have a good, hang on, 5 volts and ground. Wow, that's tight. It should work. So I'll point you straight at the VGA screen there, switch it on, and I can see straight away, yeah, that's working. Straight away I can see lines. Can you see those lines? It's working already, I think. Yeah, there we go. So there we go, it's like night and day. Oh, hang on. Why is it cutting out? That is interesting. I think what's going on here is one of the mods that Commodore recommend is to put 0.1 microfarad, 100 nanofarad cap on the underside of that jumper. This board has that mod. I actually think I need to remove that. Not all of them have it, hardly any of them have it. It's only usually if you've got a specific power supply you need to add that cap. Yeah, you can see that cap there. So I'm just going to remove that. I'm not even going to move the board out of the way, which is a recipe for disaster. I did somewhat similar to this the other day and dropped the blooming board while it was on. And we'll just reflow those points. Hopefully that will solve the problem. So let's get that back in. Make sure those are on. Make sure you've got power and ground. And let's try again. So it's on. It's whether it stays on. It's on now. It's on. It's on. It's on. It's on. It's all right now, I think. There we go. Solid. So yeah, that 100 nanofarad cap is perhaps not a good mod to do to your 2000 really. If you had that problem with the power supply, where the power supply needs that cap there, do it in the power supply itself. Don't do it on the jumper. Yeah, anyway, I'm very pleased. You can see these jail bars. Those jail bars have got nothing to do with this mod. Those jail bars are purely related to the monitor I'm using, the cable I'm using, and this particular old scan doubler here. And I thought to myself, why use an SMD cap? Well, yeah, it would be smaller and compact, but we've just took a 100 nanofarad cap off there, a mod that I'd previously done to that 2000. So I've just used that. You know, I soldered on the underside here to avoid resoldering the ground and the 5 volt connections there. Just very briefly heat the pads on this side, and I've joined that cap and just reached it over the purple wire there. So now we can hopefully, is it going to fit? We can slide this over. And there we go, there's a complete mod. So the heat shrink here, I shrunk it a little bit at the end and then pushed it inside that bit and then shrunk it completely. And the bit here, I managed to pull it over the edge of the red stuff and then shrink that. And then pull the green stuff over that and shrink that. So yeah, it's nicely encapsulated there. We've got the 100 nanofarad cap there. And obviously our input and output. Really, really simple. And it does work perfectly. As I say, these lines got nothing to do with this mod. Anyway, hopefully you found that useful. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. You can join as a YouTube member, or we have some merch. Thanks for watching. Catch you in the next video.